if you've used it a little bit, the 9-volt battery has built up already a resistance of 1 ohm. What is the simulation telling you? That the ammeter here is going to read what? 0.07, and then the voltage is 8.93. So 0.07, and then the voltmeter is going to read 8.93. Okay, so then could we check that? This is pretty simple circuit. You're just going to have 9 minus I times 1 minus 120 times I is equal to 0. Right? So then 9 is equal to 121I. So essentially you're just adding the resistor, and then you're dividing the voltage by that. We tend to, when currents are that small, we tend to say them in milliamps. So I would write that as 74.38 milliamps. That's a nice way to write it. And that's how the multimeter would read it usually. If you have a digital multimeter, it reads it as a milliamp. But the one that the simulation has, it reads it as an amp, so that's why it doesn't have too many digits. Okay, so then the terminal voltage will be what? Just you gain 9 minus you lose the IR. So 9 minus this number. Oh, this is the internal resistance. Right, so then you 9 minus the internal current run times the 1. So 9 minus 0.07438. Okay, 8.925 volts. Okay, so there's a bit of a drop off from the, you see, 8.93. Yeah, that makes sense. There's a bit of a drop off. So when is the fact that the battery is used more noticeable? When the external resistance is large or when it's small? So in other words, when I change this to something that is a small resistor, then what's going to happen? Let's say, change it to all the way the other extreme. So let's say something that has a resistance of 1 ohm. So the 1 ohm would be like a really bright, really bright rated light bulb, you see. For example, that could be one example. And then the high resistance will be a low rated light bulb. So then what happens? Look at the actual current in the circuit. It dropped. Well, actually, no, it actually increased, but it's not what it's supposed to be. And now when I connect the voltmeter across the battery, I say, oh my gosh, the battery is really used. I mean, it's not really used, but you could, in other words, the fact that the battery is used is more noticeable when you connect that battery across a resistor that is small. You see? So now let's do the numbers with that. So it's telling me that the current in the circuit is 4.5 amps. Okay, and then it's telling me that the terminal voltage is 4.5 volts. In other words, in that circuit, the 9-volt battery is only supplying you with 4.5 volts. So, so then how do we calculate the current? Well, same way, right? 9 minus I times 1 minus I times another 1 is equal to 0, right? So 9 is equal to 2I. Yeah, that's it pretty much. And then I is equal to 4.5 amps, right? So yeah, the current is high, but it's not as high as it would have been if there was no internal resistance. What would have happened? The current would have been 9 amps, right? So it is high, but it's not as high as it would have been, right? Then what's the terminal voltage? 9 minus I R int. So 9 minus 4.5 times 1. And then you get what here? It's just 4.5 volts. Yep. So what's the lesson in that? I guess what are we trying to learn? When you connect your battery with a big resistance, your terminal voltage doesn't show that much of a drop. So if you want to really know if your battery is used or not, do you connect it to a high rated light bulb or a low rated light bulb? If you want to know your battery is used. So it's better to connect it to something that has less resistance, right? Then connect the voltmeter across it. Then you catch the fact that it's used. Oh, 4.5, right? So you want to connect it to something with low resistance, and therefore low resistance is a high rated light bulb, right? So if you want to know if your battery is used, connect it with a high rated light bulb, essentially, something with low resistance. Now, what if I disconnect it? What's going to happen? What if I disconnect the circuit? What does the terminal voltage read? Can you tell if in other words, can you tell if the battery is used or not if it's disconnected from a circuit? What does the terminal voltage read? Let's increase the resistance. It's always reading 9. Why is that? I mean, what's the lesson in that? You see? So if I disconnect this, if you disconnect this and you just connect the battery here, it's always reading 9, no matter if it's old or young, right? So that means if you connect the voltmeter across the battery, you cannot tell if it's used or not. Why? Because there's no current here in the circuit. You see? Well, in reality, there's a current because the battery makes a circuit with the voltmeter. You see, there's actually a current, but the current is so small because the voltmeter's internal resistance is very high. Usually voltmeters are made with an internal resistance of like 10K or 100 kilo ohms. So the current here is so small that it doesn't draw much power from the battery. So no matter what's the internal resistance of the battery, it's always going to read 9 here. I remember this happened to me years ago, many, many years ago when I was teaching lab at some college, and we were doing an experiment using batteries, and we were trying to do like an RC experiment or something with circuits, and we kept checking all our batteries with a voltmeter, then putting them on the stock, on the carts for students to pick up. Then they would go set up a circuit. Then they would say, my current is almost 0. I'm not getting any current readings, right? So it was almost like this kind of. They were getting something like this, you know, something like this. Let's bring this back. It's kind of nice when this has actually happened, so I can tell a story about it, you know. So it's like they were getting something like this. The internal resistance was very high, and then they were trying to connect it to some circuit, you know, some circuit with a resistance, and then they were trying to measure the current here, you know, and then they were connecting this across the battery, you know. So let's say the battery's resistance. I mean, their batteries were really dead. Like maybe their internal resistance was even more than 10, you know. So then they would connect it to a circuit and they were getting like very low current. And then they would check the voltage of their battery while it's connected. And it would almost show like 1 or 2 volts, maybe even nothing, like 0 volts here. And they would say, what's wrong? And then they would disconnect it from the circuit, bring it up to me, disconnect it from the circuit, bring it up to me and say, oh, Mr. K, the battery is dead. Then I would be up in my table in the front of the class, and I would be like, okay, let me check if the battery is old or young. Oh no, it's young. It's 9 volts. You see what I mean? It's 9 volts. No, go check. You put the circuit wrong, right? And then they would go back, put it in their circuit. No, the current is dead, Mr. K. Come over. Okay, I would go over there. I would check. And then it would be like, oh, yeah, no current. Let's see. I'm going to check their circuit. Then I would go. I would disconnect. And then this kind of went on. I would check theirs. And then many groups, you know, I would check it. Wait. It's perfect battery. I would check it with the voltmeter, perfect battery. Then all of a sudden, the aha moment happened, the eureka moment. I go, wait, dang it. I did like that on the table, and I got everybody's attention. I said, class, all the ones that you brought to me that said you were dead, that you were wrong, you were right. You're not setting the circuit up wrong. Bring it up. My fault. Isn't that awesome? When you can understand it. That's the power of science. Right there, brother. I go, I understand it. Oh, they're all dead batteries. So then we went and we got new ones. We replaced them. And everything was fine after that. Everyone lived happily ever after. Okay, so that's that section on internal resistance, terminal voltage. Good lesson.